Hey, boys and girls. So we continue our lesson. I'm Dr. Long. So last week we stopped at lesson number 44. Um, okay, we already know that Kirchhoff law, actually we got two law. One is called Kirchhoff's first law, which is talking about the conservation of charge. Okay. Charge is because related with the current, is because current is actually flow of charge. So the sum of the current entering a junction will always equals to the sum of the current leaving the same junction. Okay. So if this is 2 marks, actually junction, same junction, this is 1 mark, and then current in equals to current out, this is another 1 mark. Okay. So here, Kirchhoff's second law is talking about conservations of energy. Okay, this is related with the conservation of energy. So energy divided by charge, actually this is the potential difference. Okay. Um, so here, the sum of EMF, okay, is actually equals to the sum of potential difference around a closed circuit. Okay, so this is what we learned, and then we did some past year questions. So we continue the exercise right now. Okay, today we stop at page number 7. Question number 5. Okay, this is 2018 question. A battery is connected to a network of 6 resistor. So we have 6 resistor. The potential difference across 5 of the resistor are at label. Okay, they label 5. 1, 2, 3, 4, 5. What is the potential difference across R? Okay, so at here, very easy. You can using Kirchhoff's second law to solve the question. Okay, so at here, this is the part. Okay, here this point and this point, maybe I can label this is point X, this is point Y. Okay, so the voltage at here, this part and this part, can you see that? Actually, they are in parallel. Although they drawing one of the resistor is here, but actually they are in parallel way. So if you strengthen the wire, actually these three, they are in series and it is parallel to this point. Okay, so at here you using the voltage, parallel voltage must be the same. Then you solve the question, you find out what is the voltage for your resistor R. Okay, so you can try it before I give you the answer. Farewell. No, farewell, no. Farewell, no. Okay, try again. Voltage across XY actually is 4.1 plus 3.7. So here is 7.8 volt. Then how about the voltage across R? Farewell, correct. Wesley, no. Wesley, no. Okay, that means that this part, I using my highlighter. This part, I will having a voltage which is 7.8 volt. Okay, I just add it up together. In series voltage, we add it up. Then I using another color. Okay, maybe pink, orange color. This one is actually another path which is parallel. Okay, voltage should be same as the 7.8 volt. Okay, so you try again, Wesley. Vashini, correct. Prasan, correct. Okay, so at here, the second loop, 7.8 equals to 2.2 plus 1.2 plus voltage across R. So your voltage across R should be 4.4 volt. Okay, so basically, if you are not clear, I might can draw like this. Let the three resistor together like this. Okay, so here we go one more like this. So this part is 4.1 volt. So here is 3.7 volt. So in total for this part is 7.8 volt. Here is 2.2 volt. Here is 1.2 volt. Then here unknown. Okay, so you just find it out with equal voltage. Here and here are same voltage. Okay, if let's say this question we change a little bit. What is your EMF? Can you tell me what is your EMF? If I change the question, then I say what is the EMF for the circuit provided to the circuit? Any of you can answer me this question? Type your answer in the chat box. Okay, so type to Newton Scholar, the chat box. Wesley, Wesley, are you answering the voltage, the potential difference across R, or you're answering me about the EMF? Okay, any of you can tell me if I'm asking the question is what is the EMF? Do you know that what is the EMF? No? Should be easy. Vashini, Prasan, if the question change, it's asking you about what is the EMF. So can you answer me what is the EMF across the circuit? Not across lah, to complete the circuit. Let me have a look. Fatima answering me. 16.8. How you get? No. Vashini, 7.8 volt. No. Dear, where is your EMF? Here. At the source there. EMF. Prasan, is it 9 volt? Yes. Answer is 9.0 volt. Prasan, 9.0 volt. Okay, why? Okay, dear, Wesley, correct. Here are 7.8. Although I don't know about this, but I know that this one total also 7.8. Then you don't forget, we still have one more voltage here. Okay, so that means that this one 7.8 plus this 1.2. Actually, at here, we will get 9.0 volt. Two significant figure here. If this is a paper 2, then please make sure your answer is 9.0 volt. So this is EMF. Okay, so we goes to your next page, page number 7. Okay, we goes to your next page, page number 7. This answer is 4.4. Okay, question number 5 is 4.4 volt. So at here, question, page number 8. Okay, here. Last time when we learn in year 10 or SPM, we just know that, hey, series, you add it up. Resistance in series, you add it up. Then resistance in parallel, you need to using this formula. But why and how we get this formula? Okay, in A level, then we have to learn how to derive this. And at the end, we know that current resistance should be added up together. Okay, so in the exam past year paper, they asking you to prove. So I don't want you to memorize, but we using our understanding to prove it. Okay, if not too many things you have to memorize. Okay, brain cell will kill a lot. Okay, so combined resistor in series or parallel is derived using Kirchhoff law. So actually the formulas come from the Kirchhoff law. Okay, so this one is resistance in series. So here, this is the we need to find the total resistance. Of course, we know that we just add it up together, but how? Okay, here we know that R1 plus R2 plus R3 plus. Then we ask ourselves, in the circuit, okay, current is plus together or voltage is plus together? Because at the end, we need to have a plus, okay, add it up together. So we have to think about the V and I. So we think V plus together or I plus together. Of course, we understand that in series circuit, current will be the same. So that means that in order to prove this, we have to using V, voltage. We have to using voltage because voltage is plus together. So V1 plus V2 plus V3. Okay, because using this plus at the end, we can get the answer for the derive the resistance in plus. If you're using current, I current equals to I1 equals to I2 equals to I3, how you going to get the plus together to prove this plus together? No. So, okay, so we ask ourselves in series circuit, I is plus together or V? Okay, so we're starting from V. Then after that, we understand V equals to IR. So V equals to IR, this is what we know. V equals to IR. Okay, so here IR equals to IR. This one IR total. Then I don't need to label for total or 1, 2, 3 because in series, current is the same. So plus IR2 plus IR3. Okay, so at here, current is the same in series. Okay, in series, current is the same. So at here, we should, this one can cancel. Okay, can cancel or you factorize it, then we cancel it. So at the end, our total equals to R1 plus R2 plus R3. That's all, finished. Don't trying to memorize, but we're using our understanding to derive it. Okay? So this is the part how we're using Kirchhoff's second law using this. Okay? Conservation of energy, Kirchhoff's second law to prove that total resistance in series actually at the end just add it up together. Okay? So in A level we have to know how to prove. Okay, then how about the resistance when it connected in parallel way? Okay, then here you see plus plus together. So you ask yourself, in parallel circuit, V or I need to plus together. Okay, answer is current will be plus together. Conservations of charge. Kirchhoff's first law say that the current in and out should be the same. So we are going to using the current, starting from the current to prove that resistance at the end, how we calculate the total resistance. This is the formula. So we start from the current. Okay, total current is equals to, okay, let's say this is total current. Okay, equals to, it will split into three branch. 1, 2, 3. So we just add it up together. I1 plus I2 plus I3. Okay, then V equals to IR. Your I is actually V over R. So here V over R, our total equals to V over R1 plus V over R2 plus V over R3. Okay, so at here in parallel, voltage is the same. Okay, in parallel path, the voltage potential difference is the same. So at here, that means that if you factorize it, voltage, voltage, voltage here, we can cancel. Okay, so at the end, 1 over R total equals to 1 over R over 1 over R2 plus 1 over R3. Proof. Okay, proof. 10 seconds, complete this. Then we are going to the page number 9. That we can proceed to the next page. Okay, then let's go. This is page number 8. Okay, we goes to page number 9. This is a partial question, 2017. 3 cell of EMF. So we got 3. E1, E2, E3 are connected into a circuit as shown in the figure 5.1. The circuit contains resistors of resistance R1. Okay, where is R1? R1, R2, R3, and R4. Okay, the current in the different part of the circuit is I1. I. Where is your I? I is here. I2 is here. I3 is here. Okay. The cell have negligible internal resistance. We already learned about internal resistance, but most of the case, if they didn't mention about that or they say they're negligible, then we just assume that perfect case, no energy loss, okay? No voltage loss. So use the Kirchhoff's law to state the equations relating the current. Okay, current, then you can using Kirchhoff's first law. So you try, look at it, current 1, this is I1, then I2 is here, but actually it's come here also I2. So we can label here, this is I2 also. Okay, this is I2, here is I2. So here also I2. Let me draw like this one is actually I2. Okay, how about I3? I3 is here. So here, so this is I3, we label this is I3. Direction, very important direction. So you look at me, this one is going out from the positive. So here also in this direction, okay? So current is always from the positive terminal go out, positive terminal, positive terminal. Okay, so at here, you see I3 is go in, I2 is out, I1 is out. This one is into the junction, entering the junction, leaving the junction. So at here, the first answer, actually easy. I3 is entering the junction equals to the current that leaving the junction. So actually it's I1 plus I2. That's all, 1 mark. Very easy. Okay, so next, E1, E3, R1, R3, R4, I1, I3 in the loop of W. Okay, we have a look. W, X, X, W, X, Y, Z, W. Okay, is it correct? W, X, Y, Z, W. Okay, yeah, this part. Okay, so how we are going to solve this? Okay, so here first, EMF. Okay, we look at the EMF here, battery here. So this one is going out. Then comes to here, I1. Are they in the same direction? You see, this one, current flow, this one like this. Like this. So these two are actually, if you connect them together, they will be, this is E3. Then in between, we don't know. Okay, we don't care about the component first. So this one is E1. This is E3. So look at here, this is positive. Wait, let me redraw again like this. Then after that, it's connected like this. Okay, you will find out that these two actually they're having the same direction of current. So that means that E1 plus E3. Okay, E1 plus E3. So this current also same direction. Here direction, here also. Okay, so equals to the potential difference across the component. So we look at this. From E3 come out here. This is a resistor R4. What is the current flowing through the R4? Which is I3. Because here I3, so I know that here coming and flow through the resistor 4 is I3. So I3 R4, okay, plus, then come here, R1, okay, R1 current is I1, okay, so here, I1, R1, plus, not yet finished, you see, here, R4, R1, then go back, we still got R3. Okay, for the R3, what is the current flowing through R3? This one is I3. So here I3, here also I3. So this one actually here we labeling, this is I3. So plus together, plus with the I3, R3. So this is the answer for B. Okay, answer for B, I write it here again. E1 plus E3 equals to the I3, R4 plus I1, R1 plus I3, R3. Okay? So this one, which one first doesn't matter. At the end, they just add it up together. So you maybe say that teacher, we start from W, X, Y. W, where is it? W, X, Y. Then I should starting from the I3 times R3. No problem. Up to you. At the end, they are just adding up together. I3, R3 plus I3, R4 plus I1, R1. Okay. Okay. So should be no problems, Then we goes to the next one. Which loop they want? Y, Z, W, Y, Y, Z, W, Y. Y, Z, W, Y. Oh, okay, this triangle. Okay, so at here, same things. We ask ourselves, okay, this current, is it the same direction? This is positive, go out, okay? Then here, positive come here. Can you see that actually they are crest? Okay, they are crest. So that means that these two battery, they are connected in opposite direction. This one come here, this one coming to here. They are opposite. Okay, so if you connect them together, it will be something like this. If I move the E1, E1, I move there, so this one become longer. Then here become shorter. This one is E1. I trying to move this, comes here. Okay, I'm trying to move these, come here and see how their arrangements. So the longer line actually will be facing to here, E2. So E1 longer line, longer terminal, it will facing to the E2 here. So this is E2. You found that actually they are opposite. Okay, you see, longer line come here, actually facing the longer line. Okay, so at the end at here, they are opposite. We should using one of them minus another one, bigger minus the smaller one. Okay, but we don't know which one is bigger one. Okay, the overall current, how it flow, we don't know unless they provided to us. Okay, so doesn't matter. We're just using E1 minus E2. Okay, they accept if you using E2 minus E1, no problem. Okay, what is the potential difference across the component? Okay, so at here, this triangle, so I start from the R1. So it will be I1, R1 plus, okay, not plus, because they are opposite, you see, this one positive come here, right? So I actually, this one, I should minus, okay, the current. Okay, any question? If no question, then we are going to the page number 10. Flower okay. Kaichen okay. Okay, so be careful with the sign, okay, the positive and negative. Okay, we go to the next question number 2. Three identical cells, each of the electromotive force EMF 1.5, internal resistance 590 milliohm. Okay, they are connected in parallel across the conductor as shown in figure 5.1. The conductor is composed of two cylindrical section A and B. Total resistance of the circuit is 2.2. Okay. So total resistance, that means that not only this part, but here we got internal resistance. So what they say is actually including the internal resistance. Okay. So at here show that resistance of the conductor is 2.0. That means that this part is 2.0 ohm. Then the whole circuit is 2.2. So they ask you to show. So can you try to show before I give you the answer? Okay, try first. So my suggestion is you find out the internal resistance first. Okay, internal resistance, the cell they connected in parallel way. So parallel, how you count your how you count your total resistance for the internal resistance. So we using the formula. R total equals to 1 over 590 milli. So is 0.59 plus 1 over 0.59 plus 1 over 0.59. Okay, you do calculation. What is the total internal resistance? Then after that, total resistance is 2.2 equals to the resistance across the conductor plus resistance of internal resistance. I'm using the symbol of small r to prove to show the internal resistance. So this one we want to know that conductor resistance for conductor plus internal resistance. Oh, R, small r. I write small r. Okay, so if you do it correctly, the total internal resistance, it should be 0.197 ohm. You need to press your calculator. Cannot just wait for my final answer. You need to make sure you know how to press and didn't do it careless, no careless. Okay, so at here, this one is 0.197. Then your resistance for conductor, we prove it is 2.0 ohm. That's all. 2 marks. Okay. I got your conductor is 0.003, round to 2, yes. Because in our exam, it will be accept 2 to 3 significant figure. Okay, 2 to 3 significant figure. Okay, so boys and girls, now can you try to calculate for the current in the conductor right now? Try first. Before I give you the answer, you have to think first. There's many ways to solve. You try. Machine correct. What is the current in the conductor? Okay, let me check Wesley. Wesley, no. Sean, you can message me your answer. Message to the Newton account. Newton Scholar. So we try, even though maybe we make mistake also, never mind, we try. Calculate the current in the conductor. So this is total current. Total current. Okay. So here Fawal. Fawal no. Fawal no. Try again and check again. Prasan correct. Okay. So can you guys try and then tell me? Calculate the current in the conductor. So far got 2 students correct. Okay. Current flowing through the conductor actually is a total current. Okay. So you can assume that you solve the problem for the battery, total battery first. Okay. Total. So this one what I draw is actually is total. Okay. 3 cell. 3 cells. I make it become 1. Then this is my conductor. What is the current flowing through conductor here? Current. This is total current. Okay, so how you solve total current? So total voltage equals to total current times the total resistance. Kai Chen correct. Yes, very good. Okay, so at here, V equals to IR, V equals to IR. Total resistance, total current, total EMF. Okay, 1.5 watt, 1.5 watt, 1.5 watt. They are connected in parallel way. So when they connected in parallel way, what is your total EMF? My answer is still the same, still 1.5. Okay, when they are connected in parallel, so the EMF actually doesn't increase, it still maintain 1.5. Okay, just the current at here, we can smaller the current. Still remember, if let's say this is I total, then this is I total divided by 3. I total divided by 3. I total divided by 3. Okay, so this kind of connection actually the battery can use for a longer time, but the EMF still the same 1.5. Okay, the current flowing through the circuit, don't know. Total resistance, just now they told us total resistance is 2.2. So total current, which is the current flowing through the conductor, here your answer should be 0.68 ampere. Okay, so this is the answer. Then this is not the only method can solve the problem and get the 0.68. We still can have others answer. Okay, others method to solve and then get the same answer. Okay. Okay, any question? Any question? Power, okay. Power, you know what is the mistake? So you get it, Power? Okay. Is it careless? Because just now another student also get the same answer as you, 0.75 ampere. Actually, which part you made mistake? Can you let me know? So that I can know that how to help you guys. Use the wrong resistance value. That means that the total resistance. Okay. So boys and girls, yeah, you use 2 instead of 2.2. Oh, okay, okay, okay. Okay, so boys and girls, we goes to the page 11. Okay, we goes to the page 11. Okay, page 11. 2021 Paper 2-1. Okay, that's the Kirchhoff first law. This is what I told you. If two marks, junction is 1 mark. At the same junction, 1 mark. Okay, then sum of the current equals to sum of the current out. In equals to out lah. Okay, so here the circuit shown in figure 5.1 contains a battery of EMF E and a negligible internal resistance connected to 4 resistors R1, R2, R3, and R4. Okay, so they give you voltage across the R4 is 2.4. They tell you that the current at here flowing through R3 is 0.30. Can you show that R is equals to the 4.0 ohm? Show that the R. Okay, let me have a look. Can you try? Oh, R1, R2, R3, R4, each of resistance R. That means that they are the same resistance. They all are R. Now they're asking you what is this R. So that means that this one resistance is R, this is also R, here also R, and R4 also R. So they ask you to prove R is actually 4.0. So using Kirchhoff first law, Kirchhoff second law. How I know this R actually is 4.0 volt? Give you some hints. Here I got the voltage. I want to find the R. V equals to IR. I don't know the current. So your task is you have to find the current. You have to find the current. What is the current flowing through the R4? Teacher, I don't know because here I don't have the current. I know this is 0.3, but I don't know about this. You know, dear, you know. So try to find the current flowing through R4, or I say total current. Then you got the voltage. You can find the resistance R. Vashini, yes, 0.60 ampere for this current. Okay, the total current here, I say total current is 0.60 ampere. Why, dear? Why? Because this part, resistance current flowing through is 0.30. That means that this resistance also resistance R, they are same resistance. Then the current flowing should be the same. So that means that here we label this is also 0.30 ampere. They comes to the junction at here because they are entering the junction. Entering, this two is entering, go in, this one go out. So Kirchhoff first law, add it up together. In equals to the out. So 0.3 plus 0.3, you get 0.6. Okay? Then after that, when you get this current, you get the voltage, then you can find the R. Okay, so here V equals to IR. Okay, this one is R4. Okay, R4. So current flowing through R4, this is 0.60. Okay, then voltage across R4 is 2.4. The resistance for R4 we don't know. So at the end, you press your calculator, you should get 4.0 ohm. Okay. Any question? Is it okay? So this one, you're using Kirchhoff first law, okay? Conservation of charge. Current in equals to current out. So one of the concept is you have to know R out. If they are the same, so current should be the same. If let's say current resistance at here is R over 2, that means that the resistance become half of it. So what is the current flowing through here? Current should be bigger, double, become 0.6 at here. Why? Because your resistance become half of it. So this idea you have to know, okay? This idea you have to know. If your resistance become half of it, current will be double up, okay? If let's say this one is 2R, resistance become double, then what happened to your current? Then your current should be half of it. Okay, resistance double, then current half of it. Because resistance become higher, it will limit the current to flow. So this one becomes 0.15 ampere. Okay, this concept you have to know. Same resistance, same current. Then after that, double up the resistance, current will be half of it. If your resistance half of it, then your current will be double up. So at the end, based on this knowledge, we can find the total current flowing through R4. Okay? So next, determine the EMF of the battery. Okay, think. Before I give you the answer, so try. So show me your answer. Let me check. Vashini, correct. Wesley, yes. Wesley, two significant figure and unique. Fawal, yes. Fawal, two significant figure. Huh? Fatima, no. Fatima, no. EMF is the total in the battery. So Fatima, what you give me is actually on this part. Now EMF is this part. Okay, this part. Let me check Fawal. Okay, correct. So dear, EMF is this part. Okay, this is the what we say. Oh, okay, Kirchhoff's second law. Okay, conservation of energy. So EMF is equals to the total potential difference across the component. Okay. So let me check Prasan. Correct, Prasan, two significant figure. Okay, here, dear. Here is 2.4. Then your R1, what is the voltage? It should be also 2.4 volt. Because here is total current. This one going back. Here come out from battery is total current. Going back to the battery also total current. So what is your total current? Total current is 0.60 ampere. So that means that this one 0.60 ampere. Same current flowing through, same resistance R, then your voltage should be the same. So for the first part, this is 2.4 volt actually is for the voltage across the R1, okay? So at here, question number 2, okay, EMF, EMF is actually 2.4 volt plus, okay, this is a parallel circuit. Okay, parallel circuit. So you should find one of them enough because they will be the same voltage. This path voltage and second path of the voltage actually will be the same. So we just think of either one, okay? They will be the same. So look at here, 0.3 ampere, then resistance is the same. Resistance is the same, but current become half of it. Okay, current become half of it. So your voltage should be V equals to IR. What? Dear, here V equals to IR. If your current is already divided by 2, then your voltage that you get also divided by 2. So at here, it should be 1.2 volt. Okay, 1.2 volt. If you still don't know, it's okay. Just now, you do calculation and you found out that the R is 4 ohm. So this one is 4.0 ohm. So your voltage across this part, V equals to IR, R3 and I3. So current is 0.3 times 4. Your answer is 1.2 volt. See? You also can do calculation to find out. Okay? So at here, 1.2. Then these two paths is the same, and then they are not added up together. For parallel circuit, voltage doesn't add up together. So it's 1.2. Then the last part at here is 2.4 plus 2.4. So answer is 6.0 volt. Okay. This is the answer for second part. Is that clear? If clear, give me some reaction, then we can proceed. Okay, very good. Sean able to follow? Okay. Okay, Sean, okay. Okay, dear C. The battery in B. Okay, in B. Battery in B. Oh, okay. This is B lah. Question B. The battery in B is replaced with another battery of the same EMF, but right now with an internal resistance. Cannot ignore. Just now is with negligible internal resistance. Now still the same things. I changed the battery, but right now the internal resistance we cannot ignore. Okay, state and explain the change, if any, in the total power produced by the battery. So think your total power, any change. If change, then tell me why it's change. Wesley, your first part is correct, but your explanation is wrong. Yes, Prasan correct. Prasan correct. How about others? Okay, EMF is the same. So here, EMF formula. E equals to, we understand V plus I times small r, right? Or we say E equals to I, R plus small r internal resistance. Okay? So from here, if your internal resistance here increases, we cannot ignore. That means this part, we have this R. So what is your total resistance in the circuit? Your total resistance will increase. Okay, then here again, the EMF is the same, it's constant, it doesn't change. So your current in the circuit will decrease. The current in the circuit will decrease. Okay, I check. Washini one, resistance increase, current decrease. Yes, very good. Okay, so when current decrease, power decrease. Yes, correct. Okay, Wesley, current is smaller. Current is smaller. Yes, correct. So dear at here, what happened to your power? Power, we got three formula. Either one also can, okay? So I can say that P equals to I square R or P equals to VI. P equals to VI. The V at here actually is the EMF, what? Voltage in the battery, okay? We call it as EMF. So it's constant, it doesn't change. But the current decreases. Current decreases, so your power should be decreased. Okay, this part decrease, this part decrease, so your power also decrease. So at here, state any change, okay, in the power. So we write down total power decreases. Okay, why? Because total resistance increase. Because right now, not only the four resistor, but we have some internal resistance. Okay, when total resistance increase, current decrease. Okay, this is the answer. Okay, the D question actually is related with let me think, last chapter, yes, resistivity. Okay, still remember what is the formula for resistivity? You have to memorize. I give you hints today. Rho L over A. Okay, last time we practiced a lot for this question. This kind of question. Okay, so here resistor in the circuit of 5.1, figure 5.1 are made from nichrome wire of uniform radius. So this one is R. The length is 0.7. So this one is length L. Okay, the problem is in my formula there is no small r radius. So we have to make the area in terms of pi r square. Okay, so at here equals to rho L pi r square. Okay, or here if they give you diameter, it will become area equals to pi d square over 4. So this one we have to know. Okay, can you try to find the resistivity? 3 marks. Wow, a lot. One more they want to test you is, do you know the prefix? It's not like looking the value, then you just put in formula without thinking about the prefix. Cannot. Okay, Prasan. Correct. Prasan, very good. Correct. Formula, substitution, final answer with unit. Vashini, correct. Very good. So we give others some times to try. The rest of you have to try. We are waiting for you. Okay, so R is equals to resistivity. We don't know. Okay, the resistance. Okay, what is the resistance? Is 4. Okay, so this one is from figure 5.1. So just now we already count and we know that the R is 4.0. So actually something missing. It must be provided in the previous question. So you go and see. Okay. Wesley, no. So later on, Wesley, you check which part you made mistake or maybe you press calculator wrongly. Okay, so this one resistance for the resistor, okay, is 4.0 ohm. Then resistivity unknown. The length is 0.67. Do you know that 67 is very famous? I don't know why my students so excited when I say 67. Then they are everybody happy. I don't know why. I know there's something in YouTube or what, but I can't get the point. I don't know why so funny. Okay, pi R240. What is this symbol? This symbol is times 10 power of negative 6. Okay, times 10 power of negative 6. So times 10 power of negative 6 square it. Okay, square it. Any of you know the what 6 7? Why so funny? Oh, you also don't know. Okay, here my answer 1.1 times 10 power negative 6 ohm meter. Okay, ohm meter. Here they already tell you ohm meter lah. If you really don't know, then you can rearrange. Rho equals to RL over RA over L. So this one is ohm, then meter square divided by meter. So at the end you get ohm meter lor. Okay, no need to memorize. We can derive. So this is the answer. Fawal, yes. 10 power of negative 6, yes. Wesley, yes. Washini, you know the 6 7? Do you know? Kai correct. I know what is it, but it's not funny. Yeah. Yeah, I don't know why they are so excited. Washini, you go and search. I didn't get the point. I don't know why they are so happy. Okay, so Dana, we goes to the next page, page 13. Is it okay? 6 7 is like nonsense, but also the height of a basketball player. Really? It's the height of basketball player? 6 7? Okay. Then we goes to the 6 7 come from a music video, and then a lot of people said it. Music video. Yeah. I think I saw the video is singing something. Okay, dear. Number 4, Kirchhoff first law. You see, just now also Kirchhoff first law, but here is right now is only 1 mark lah. Okay, so by the way, no matter 1 mark or 2 mark, we give the perfect answer for it. Okay, a battery of EMF 12.0 volt and internal resistance R is connected to a filament lamp. Okay, we have a filament lamp and a resistor. Oh, okay. The current in the battery is 3.6. So here is 3.6. Going back also 3.6, dear. Current is the resistor is 2.1 ampere. The IV characteristic for the lamp is shown in the diagram 6.2. Okay. This is for lamp. Okay. Every time you read the question, please read it. Do not skip any sentence. Maybe you will skip some important information. So this one is for the lamp. Whatever we thought is about the lamp. So at here, lamp is here. Okay, next. Determine the resistance of the lamp. I want to know resistance. That means that I need to know V and I. Am I right? I need to know the V and I. Okay, so do you know the V for the lamp? We don't know. But can you know the I? Then from I, find the V. Okay, using Kirchhoff's first law, what is the current at here? For the current flowing through the lamp, then from I, you find your V. Then with these two information, you can find the resistance. Okay? Plus 1.5, no? Oh, 1.5 is current, yes. Then you need to continue until you find the resistance for the lamp. A kid says 6, 7 and did the hand sign. Yeah, they got like this 6, 7, then they were happy. I never able to follow the train. I even cannot get the train. I don't know why so happy. Then I go to every single class, then I say 6, 7, then every student right now, they are so happy. Okay, even small kid also, even small kid like 7 years old, they also know 6, 7. Okay, dear. Okay, here just now our friends already told us this one is 1.5 ampere. Okay, so this one is entering the junction. Now must be go out and go out, split. So 1.5 is 3.6 minus 2.1. Okay, it's 1.5. So from the graph at here, 1.5. So this is 1.5 come here and then going down. 4 point what? This is 4.4. Okay, be careful. Here is 4 to 6. So this one in between is 5.0. So this one is 4.4 volt. Okay, so at here, my answer is 4.4 volt divided by the current is 1.5. So our answer should be 2.9 ohm. 2.9 ohm, okay? 3 marks at here. Formula, substitution, final answer. For me, I will show on the graph how I get this 4.4 lah. Okay? And also, I trying to make sure I didn't read the value wrongly lah. So by drawing the line is more safe. Okay. Kai correct. Okay, next. Determine the internal resistance. So if internal resistance related with the formula of EMF, okay? So E equals to the V plus IR. V plus IR. Okay, so can you try what is your, because we want to find this R, right? So you have to think what is your EVI, okay? Try. E, then V. Okay, let me check your answer. Pawan correct. Good job. Wesley correct. Be confident. Yes. Washini, yes. Okay, so dear here, E equals to V plus IR. I do it at here lah, so that we can refer. Hai Qian correct. Yes. Okay, VE is the EMF. So at here is 12. Okay, equals to the V. V is the voltage across the external circuit. Okay, so this is the battery. This part is called external circuit. So this V actually is this part. Okay, then at here, dear, this is two paths. They are in parallel. So we just need to know the voltage for either one. That's all. Okay, either one. So for example, at here, this one 2.1, I don't know about this. Then I cannot using this to find the voltage. I can using just now this one, 1.5 ampere. When 1.5 ampere for the lamp, the voltage is 4.4. 4.4. So that means that this one, it will have 4.4 volt. Agree? This part, 4.4 volt. Here also 4.4 volt. Okay? Then after that, the internal resistor at here is R. We don't know. Then this is 12 volt. Okay, so this one is 4.4 plus current flowing through the internal resistance. So what is this current flowing through? This is called total current because beside the battery. This one is come out from battery going in into the battery. Side of the battery actually is total current. So what is the total current? Here is 3.6 ampere. That means that going back, it should be also 3.6 ampere. So this one, 3.6 times more R. Your R actually should be 2.1 ohm. I draw again the circuit and I show you this is, I assume that I combine them together. Since they are parallel, after I combine their voltage, still the same is 4.4. Sean, correct. Sean, correct. That means that you get the idea. So if okay, then we go to the next page at here. This is the part that last week, I think we also did the similar question. Okay, here. Initial energy stored in the battery is 470 kilojoule. Assume that EMF and the current in the battery do not change with time. So E do not change, I do not change, okay? Calculate the time taken. We want to find T. For the energy stored in the battery to become, so this one is final. That means that 470, then it will drop to 240 kilojoule. Okay, from 470 kilojoule drop to 240 kilojoule. Okay, so can you find out how long the time it need to drop until the energy left 240 kilojoule? So here energy formula VIT. If not mistaken, we did this kind of question last week. I remember. Okay, can you try? So for the E, this one E, dear, you see, you will confuse if you are not very familiar with the formula. This one E is called energy. It's not EMF. It's not EMF. Just now, this one E is called EMF. So you have to know, okay? So here, can you try? What value for the E you should put in into the formula? Sean, no. Sean, you try because 470 kilojoule drop to 240 kilojoule. In between, what is the energy loss? So we want to find this energy loss. Put in here. Then you continue. Fawal. Fawal, no. I think maybe some prefix you didn't use it properly, but the figure is there. Oh, Wesley, no. Wesley, no. Prasan, no. How come? Vashini, Vashini. 470 minus 240 is actually we lost in, okay, in between here. We need to lose 230 kilojoule of energy. So 230 times 10 power of 3 equals to, what is your V at here? Here, they're talking about battery. Battery. Vashini. Vashini, yes, I want two significant figure. Fawal, two significant figure, but your answer is correct. Taiqian, correct. Good job. Okay, here, dear. Battery. So battery at here, the V actually is talking about EMF. okay, EMF for the battery. So in our question at here, our battery is 12. 12. So we should put 12 at here. Okay, Fawal. Fawal, you didn't see the kilo, yes. Prasan, yes, correct, Prasan. Wesley, correct. Sean, correct, yes. So what is the current? Current flow in the battery, that means that current that we should use is total current. Okay, 3.6 ampere. So at here, 3.6 ampere times T. So what is your T? 5300 second. Okay. If not mistaken, last week we did this question, similar question, also saying that the battery is dropping. Okay. I don't have the worksheet right now. It's okay lah. So remember, you have to find how much from initial after final, how much energy loss. So in order to lose this 230 kilojoule of energy, how long the time we need? This is the way how we solve. Okay. Then we go to the next page, page 15. Give me reaction so that we know that we can continue, proceed to the page 15. Haichen okay, Vashini okay, okay, Fatima okay, good job. Flower okay. My dear, this is 2024. State the Kirchhoff second law. So Kirchhoff second law is sum of the EMF equals to sum of the potential difference. If 2 mark, then you have to mentioning around a complete circuit. Okay, around a closed circuit or around a complete circuit. Okay. So here, state the conservation's law that give the Kirchhoff second law. Kirchhoff second law is talking about the EMF equals to the potential difference, voltage. So voltage is actually work and energy divided by charge, right? So this one is conservations of energy. Energy. Okay? So no need to memorize. But if you know the potential difference is W over Q, the W is energy. So it's conservation of energy. Okay? If you understand the concept, a lot of things we no need to memorize. In physics, it's study smart. Okay? A circuit contains a cell of internal resistance R and two resistors of resistance R1 and R2. Okay. The potential difference across the two resistors is V. Two resistors, we have a voltage V because they are connected in parallel. So they will be the same. Voltage will be the same. Current in the cell, total current. Okay, so this is total current in the cell is I. Using the Kirchhoff's law to show the total resistance actually is using this formula. Okay, dear, do not refer. Using the technique that I teach you just now, how and which law you should use to prove that actually the total resistance is this formula. Okay, 10 seconds for you to prove. 10 seconds should be enough lah. Parallel, what is actually plus it together? Is the I or is the V? Okay. Do I need to prove for you? Should be no need, right? Is it okay for you to prove without referring to the notes just now? If yes, you're able to prove, you give me reaction. So I know that you get the point. You know how to do. Okay, Prasan okay. Fawa okay, Vashini okay. Kai Chen okay or not? Kai Chen able to follow? Kai Chen okay. Sean, Sean, without referring, do you able to get the formula, derive the formula? Okay, good job. Okay, dear, next here. The EMF of the cell is 1.5 volt. So here I label 1.5 volt. Okay, next. When the values of R1 and R2 is 10 and 15. Okay, here I label. This is 10 ohm and this is 15 ohm. Okay, the the voltmeter at here, we will get 1.38 volt. Okay. Calculate the internal resistance. Talking about internal resistance, so basically the formula will be E equals to V plus IR to find your R. What is your R? That means that the rest of the information you have to find out by yourself. Okay, can you try? Okay, try. I don't have I, teacher. Then do you able to find I? Okay, those who have no idea, I give you hints. I give you some hints. I don't have I, then I must know what is my I. I have to find out first. Okay, so what you can do is you solve this part to become a single resistor. Okay, then when you got the resistance value, you got the voltage, then you can find the I. Okay, you can find the I. Then the V is actually 1.38. The E is actually 1.5. Now the problem is you don't know the I. So you have to think how you find the I before you find the internal resistance. Yes, Kai Chen, very good. You are good in electricity, is it? Correct. Kai Chen get the answer. No. But so far today, your all answer is quite good. Your answer all correct today. Prasan correct. Yes. Vashini correct. Okay, how we solve this? Step 1, find the R1, R2 resistance when they combine together to become one. Wesley correct. Okay, so at here, 1 over, or I say R is actually 1 over 10 plus 1 over 15, inverse it. Okay, so I will get my R is actually 6 ohm. That means that this one, okay, this part actually is here. I will get 6 ohm at here. Okay, then I have V equals to IR. So my V is 1.38 plus equals to I times R is 6. So your current is actually 0.23 ampere. This is the total current. So this one is actually 0.23 ampere is the current flowing through the circuit. Okay, so this one no space. I equals to 0.23 ampere. So 0.23 ampere times your R. Your R actually will get 0.52 ohm. Okay, I write down the step. This is step 1. This is step 2. This is step 3. From the step 3, actually we know we need to find the internal resistance. So we find out the formula first. Then inside the formula, every single physical quantity, we need to find the correct value. So E is the battery EMF, so 1.5. V is the voltage at the external circuit, which is this part. Okay, external circuit. So the voltmeter, they already told me 1.38. So this is my answer value, 1.38 for the V. Then current, we don't know. So we have to think how we solve it. Because this question, they give you 3 marks. Of course, they won't be directly easy for you to solve. You need to find some few steps. So we solve this part, become a single resistor. Then after that, with the voltage, we can find current. Okay, then put it in. You get the answer 0.52 ohm. Okay, if no question, then we go to the C. Okay, next, let's go. So this is the answer just now I write it here. This one, okay? 0.52. Okay, next question, C. A third resistor is added in parallel with R1 and R2. Okay, so just now it's actually already got 2 connected in parallel way, like this. So right now it become 3 resistor. Okay, so at here, state and explain the effect if any of these change on current. If you add another third one in parallel again, so what happened? What change in the current? And why? State and explain. That means that you tell me your final answer, any change, and then tell me why you say so. Okay, explain why. Why need to take so long time for you to think? It's quite straightforward, dear. Fatima, you have to think in parallel way, total resistance is increase or decrease. Think, or you put some value and you find it out, the resistance is actually increase or decrease. Sean, same thing, you think if I add another third resistor in parallel, actually overall resistance here, compared to just now, actually overall resistance is increase or decrease. Then you only can answer current should be increase or decrease. Okay, let me check Wesley. Wesley, correct? Vashini, correct. Vashini, correct. Prasan, Prasan, no. Prasan, no. But your because behind answer is correct, but the front one is wrong. Current is wrong. Fawal, no. Fawal, no. Okay, Fawal. Sean and just now, I can't remember another one. Okay, here dear, listen to me. If add one more resistor, last time I got teach you, well, this one, let's say only, let's say, okay, let's say, example, this one is 6 ohm. This one is 6 ohm. Here I add another. Of course, I just simply put a value. It's not related with the question. I just telling you in parallel way. Actually, overall resistance will be increased or decreased. Okay, last time I got mentioned this one total current and total resistance will be 6 divided by 2. Shortcut. Right? Shortcut path. 3.0. 3.0. Okay. Okay, then this one is 6 divided by how many of them is similar resistor and then they connected in parallel way. Okay, this one is 3. We got 3 resistor having 6 ohm. So our answer will be 2.0 ohm. So can you find out that if you add one more resistor in the circuit, actually you are decreasing the overall resistance. Will be decreased. Okay, will be decrease it. Okay, so at here, if your total resistance decrease, that means that this part total resistance decrease, that means that your current can be higher. Get it? This part, if your resistance decrease, because here, okay, this one if I want to explain in another way is E equals to V or I times R plus R, okay? Here, if we having this resistance, this part decrease, okay, decrease. So EMF is constant, doesn't change, like Vashini say. So Vashini, your understanding is very good. So what is your current? Current will be increase. This part decrease, then current will increase. Okay, so at here, current in the cell. So at here, we say that current in the cell, current will increase. Okay, current will increase because total resistance has decreased. Okay, EMF is not changed. So here, if you want to know why EMF is unchanged, if here got 3 mark, then you mention about the EMF. Okay, so why here? This is my answer. Okay, I write the formula at here. E equals to I times R plus R. So your this part R is decreased. Okay, so your I should be increased. Then this one E actually is unchanged. That's why your current in the cell should be increased because total resistance decrease. Okay, so next, the potential difference measured by the voltmeter. Okay, so what do you think? Well, no. Well, no. Voltmeter will change. Voltmeter will change. E equals to V plus IR. So this is reading from voltmeter. E is unchanged. Okay. Current not constant, dear. Fatima, current not constant, but the front part is correct. Fawal, yes, but why? Vashini. Okay, I read out the Vashini answer. When current increase in cell, greater potential across internal resistance. So potential difference measured by voltmeter will decrease. Perfect. Yes, this is the answer. Okay, Prasan, potential difference decrease because current increase. Okay, when current increase, what's going on? When current increase, what's going on? Okay, so at here, look at me. When we connected one more third resistor, then at the end, total resistance decrease. When total resistance decrease, that means that this one, the current will increase. If current will increase, the voltage across the internal resistance will increase, right? Okay, E is the same. E is the same. Then V at here, because behind here already giving a greater share, okay? Greater potential difference across the internal resistor. So that means that here we will receive less voltage. Okay, this is the answer. So I write it down first. Okay, potential difference on voltmeter will decrease. Okay, why? Because because greater current, okay, cause a bigger drop in potential difference across, this one I erase, across the internal resistance, full stop. Okay, because this part is greater, so voltmeter will get less share. Okay, the most important, the reason is because of this. If you only mention because greater current, no mark. Okay, then greater current, then why? Why my voltmeter will be decreased? Okay, we're reading for the voltmeter, why decrease? It's because the internal resistance there, it get more share, it get more potential difference already. Okay, is that clear? Is that clear, dear? Yes or no? Prasan okay? Vashini okay? Power okay? Wesley, Sean, yes, good job. Okay, so dear, next Kirchhoff first law. See, dear, this have to know. Actually, no need memorize. We know what. Okay, a cell with the internal resistance. Okay, Kirchhoff law to show the total resistance now is R1 plus R2. How you get this? Like 10 seconds. Prove it without referring your notes. Prove it. Just now is in parallel. This question is in series. Good for you to see the difference. Do you able to prove? If you're able to prove, you let me know. Then we can proceed to the next page. Power able to prove? I haven't take attendance. Okay, later. When you solve C, then I take attendance. Prasan okay. Kai-chen okay. Okay, Like dear, here. EMF in the cell is 1.5. So for me, I will label here 1.50 volt. Okay, the value of R1 and R2 is 10 ohm. So 10 ohm and 15 ohm. Oh, just now in parallel, is it same value? Yes, you see, this question is in parallel, 10 ohm and 50 ohm. So right now they change. The question becomes series. Okay, the value is there. Terminal across the cell is 1.35. Okay, terminal potential difference across the cell is 1.35. What is this? This is the voltmeter, reading from voltmeter. This is not a EMF. EMF is here, EMF. Then we found out that this one is voltmeter reading V. So this is V. Calculate the internal resistance. So E equals to V plus IR. What is your R? So you have to solve. Now you got E, you got V. The problem is how you find your I. Same, just now, you see, dear? We also did this question just now. Ask you to find internal resistance. So you got the E, you got the V, you don't know the I. So we're trying to find I. Right now, similar technique, but for the series. So you try. I take attendance first. Chen, yes. Kasan, yes. I didn't see Yue Ting. I think no. Yue Ting today absent. Fawal, yes. Fatima, yes. Jahan, yes. Tony, no. Manjo absent today. Going for holiday. Wesley, yes. Danish, no. Sean, okay. Okay, let me check the answer. Vashini, correct. Wesley, no. Kai Chen, correct. Kai Chen, correct. Then we're using the similar technique to solve. Just now also the same. So E equals to V plus IR. E is the EMF 1.5. V is the, here, terminal potential of the cell is 1.35. This is the V. Okay, this is measuring when the circuit is closed. Okay, the voltmeter reading 1.35 actually is measuring the external circuit. So this one is 1.35 plus, I don't know the current. That is the problem. We don't know the current. Okay, so how? So let me have a look. The 1.35 is the voltage, right? From here. From here to here. This is the voltage, 1.35 volt. Okay, so V equals to IR. External circuit is 1.35 equals to the current. I don't know. Do you know the resistance? Across these 2 points, the resistance is 25. Okay, 10 plus 15 is 25. So your current should be 0.054 ampere. 0.054 ampere times your small r. Your small r should be 2.8 ohm. Yes, Wesley, correct. Farwell 2.8. Is it a substitution wrongly or what? If you compare these two questions, one is series, one is parallel, but the technique how we solve is the same. Okay? You need to read the question and understand what is this value represent. Okay? So is that clear for this? This is question C. Is it okay? Can we proceed? Yes, okay. So next, so this one answer is 2.8 ohm. Okay, here. A resistor of resistance R3 is added to the circuit. Okay, so that the circuit is shown in figure 6.2. State and explain the effect, if any, of this change on the current in the cell. That means total current. What happened to your total current here? Try again. So if I add R3 in the circuit, what's going on and how it affect your current? Let me check. Washini. Very good. Washini answer is very perfect. Okay. So she said that current in cell increases because total resistance in the circuit decreases. Okay. And EMF actually is constant. So at here, if once you connect the resistor in parallel way, it will reducing the total resistance. This one is confirmed. Okay. If not confirmed, then you put some value, then you do some calculation, then you will know. Okay. If let's say in the exam you confuse, it's increase or decrease, doesn't matter. You put some simple value lah. Let's say like this one is 4 ohm, let's say 6 ohm, 6 ohm, then this one 6 ohm, then you're trying to solve it using mathematics, then you see total resistance compared to just now only got 10 and 15, which is 25 ohm. So actually becomes increase or decrease. Then you try lah. So let's say this is 10 ohm, this is 15 ohm. So you can put whatever value at here 10 ohm and then you do some calculation and see. Okay, by the way, no need to do calculation. We also know that connected in parallel way, total resistance here, this part, total resistance, okay, the R actually is decreases. When decreases, so E equals to V plus IR, or we say E equals to I, R plus R. Okay, so this part is decrease. Okay, this is constant. So your current should be higher current. Okay, So at here, we write out the answer. The current in the cell will increase. Okay, why? Because total resistance has decreased and EMF is unchanged. But here, only 2 marks, so 1 mark allocated to this current resistance increase. Another 1 mark is current increase, 1 mark. If let's say got 3 marks here, then you have to mention what happened to your EMF. Okay, so this is the answer. Okay, next. What happened to the terminal potential difference of the cell? Potential difference of the cell. That means that your voltmeter reading. Reading from your voltmeter, which is your voltmeter, which is the big V. Okay, think and then tell me. What do you think? If I add one more resistor in the circuit parallel way, so how it affect my voltmeter reading? So electricity chapter actually they combine a lot of knowledge in one question. So about the EMF, about the internal resistance, this is last week lesson. Okay, any of you got idea? What happened to your voltmeter? Just now similar, dear. Just now similar with just now the question here. It's similar. So can you see that series parallel? The way they're asking is almost the same. What happened to your current? What happened to your potential difference measured by the voltmeter? It's same question, but just different type of connection only. Okay, so you think about this. Using this to think what happened to your V. So you want to think about V. Then when you connected one more resistor at here, what happened to your total resistance? What happened to your current? Then what happened to your V voltmeter? Let me try. Vashini say when current increase, greater potential difference across internal resistance, terminal potential of cell decreases. Correct. For a while, will V increase? No, it should be decreased. Voltmeter reading should be decreased. Okay, Fatima, voltage increase as resistance decrease. Voltage increase? No. Okay, dear, here, look at me. E is equals to I R or V lah. Okay, V plus I times small r. Okay, so at here, dear, I want to know what happened to this voltmeter reading. Terminal potential difference of the cell is actually reading from the voltmeter. Okay, here I understand that my total resistance is actually decreases, so my current actually increases. Okay, then after that, this part, V for the internal resistance, it get more voltage. That means that voltage from voltmeter will get less share. Okay, get less share. So at here, my answer is terminal potential difference of the cell. The potential difference of the cell decrease. Okay, why? As the current is greater and there is a larger potential difference across internal resistance. Okay. Okay, 2 mark is here. This one answer decreases. Why? Large potential difference across terminal resistance. Okay, current is larger is not a extra point for you. Is you have to know. Then explanation most important is because you understand for the potential difference across the internal resistance actually become higher because the current is higher lah. Okay, so this is the 2 point. Fatima say, why can't we just using V equals to IR? Okay, if you are talking about V, what meter reading at here? Okay, when your total resistance is decreases, your current also decrease, while your resistance also decrease. Okay, so we are not going to using V equals to IR because both I and R are changing. Okay, so the correct way how we do comparison, maybe I can draw another circuit for you guys to have a look. Okay, I draw in this way. Internal resistance also a resistor. Okay, so this one is a big resistor that I combine the three resistor. Let's say only I don't know what is the reading, or did it mention? No. Okay, let's say at here is 1.5 volt, let's say. Okay, then let's say at here is like lower. Okay, then this one, when it lower the current at here, okay, just now at here our current is 0.054. Now our current become higher, so maybe I just put 0.6 ampere. It become higher current. Okay, it become higher current flowing through this small r. That means that this part, it will receive more voltage. It will receive more voltage for this part because higher current come and times with this r. Okay, so higher current come here, this higher current come here, but my resistance also changes. So you cannot using V equals to IR to find this, whether it will increase or decrease. But we can understand that the current become higher, so this part actually they will get more share because I times R, my I is higher, so this part IR voltage across the internal resistance is become more. So let's say 1.5. Initially, this one maybe is only 0.2. Right now, it becomes 0.5. That means that here only receive 1.0, something like that. Just now, maybe it's 0.2 volt. 0.2 volt, yes. So right now, because current increase, so maybe this part becomes 0.5 volt. Then here becomes 0.1 volt. It will decrease. You get it what I mean? Okay, how about others? Did I explain clearly about this part? No problem, Fatima. Okay, so boys and girls, I want you compare these two questions. These two questions, the way they asking is similar. Just using the what series and parallel circuit only. That is the difference only. Okay, series and parallel. Okay, if no question, can we proceed to the page 19? Okay, good job. Okay, two battery. Oh, this one, you see the look. Okay, here. Two battery, each EMF 6.0 volt. Okay, and negligible internal resistance are connected in series with three resistors. Okay. You can ignore this one first. So basically, the whole circuit is in series. Voltmeter is just a apparatus to measure the voltage. It won't changing any physical quantity in your circuit. It won't change your voltage. It won't change your current. It won't change your resistance. Okay, it's just a apparatus only. Okay, here resistor X is here 4.0 ohm. Resistor Y is 1.5 ohm. The resistance R. Oh, okay, this one of the variable resistor is changed until the voltmeter in the circuit reads 0. Oh, okay, the one read here becomes 0. Okay, that means that okay, here this part becomes 0. Then ask you to calculate the current in the circuit. Okay, this one I. Okay, boys and girls, can you try? Okay, we can think about this part first. We can think about this part. Okay, here I measure the voltage. Is there any voltage drop between these two? Answer is this is 0, which means that 6 volt is provided for this 4 ohm, and voltage drop for this part is exactly 6 volt. You get what I mean? Like the whole circuit we say total EMF. Okay, EMF is equals to the potential difference. So for this part is exactly the same. Okay, this part is 0. That means that this 6 volt is provided to it, exactly provided to this resistor. Okay, voltage drop for this part is exactly 6.0. So the EMF equals to the potential difference. Okay, your EMF for this part so I'm using my highlighter to show you. Now I'm talking about this part. Okay. Okay, so this one is the EMF is 6.0. Okay, you minus the current, or we say the potential difference here across the 4 ohm. It's actually 0. Okay, it's actually 0. Then 6.0 minus your I times your resistance is 4 equals to 0. Okay, what I provide is actually used up by this 4.0 ohm. That's why when I measure, no more voltage. Okay, voltmeter becomes 0. This is the meaning. Okay, so your current for this question, your current should be 1.5 ampere. This one is A. 1.5 ampere is your answer for your A. What your provider is exactly for this potential difference. Okay, so this one 6 volt equals to the I times 4. Equals to I times 4. Okay, is that clear, dear? No response. Power okay, Vashini okay. Okay, Kaichen Prasan, okay, good job. Okay, what is your resistance R? Okay, so can you try? You think about the whole circuit right now. Okay, you think about the whole circuit right now. So maybe I can redraw. You do it and try it. Okay, whole circuit. Let me check. Any of you can answer? Can repeat. Oh, Wesley, which one you want to repeat? The A, huh? Is it A? Well, 2.0. Oh, Prasan, correct. Wesley, is it you want to talk about this? Yeah, okay. Well, let me check others. Fawal, correct. Okay. Wesley here. I put the voltmeter at here. I want to know the voltage across these 2 points. If this is 0, meaning that this point voltage and this point voltage are the same. So we consider this part, we consider this slope. No need to think about this. Okay. So 0, that means that actually the voltage will be used up. This is a provider. Battery is a provider. Okay. It will provide 6 volt. Then resistance is the use up one. It will use the voltage provided by the battery. Okay, so at here, if you are exactly use up the 6.0, then at the end, 6.0 volt minus 6.0 volt, you get 0 because you use up all the voltage already. That's why from this point to this point is actually the voltage is 0. Okay, you can think like this is a resistor, okay, or this is maybe a very very small resistor. Then you will find out that this one is 6.0 volt. That means that there is no voltage giving for this part. Okay, if here exactly use up the 6.0 volt from the battery, that means that there will have no voltage will be given for this part. That's why when we're using the voltmeter to measure it, we get 0 volt. We get 0 volt. It's because this resistor use up the whole 6.0 volt. So 6.0 volt minus the 6.0 volt, we no more any voltage left. So when we put the voltmeter at here, we get measure and we get 0. But see, it's okay. Washini correct. Okay. Okay, so a battery is provider 6.0 volt. Then it provide to the resistor. Okay, then resistor if use up all, that means no voltage left over. So when you put the voltmeter to measure, you will find out that it's 0. That means that it's used up all the EMF from the battery provided by the battery. Okay, here your answer should be 2.5 ohm. Okay, this part you just think about the whole circuit. You will find out that the whole circuit, this is positive. Longer line is positive, here also positive. Okay, you look at this longer line connect to here. So you can imagine this is longer line come here. So they are in the same direction, you know. Okay, wait. Let me erase first. Okay, or we label the current. So current flow out from here. This is current. So this one positive also, current flow out. So can you see that the whole circuit current flowing in this direction? They are flow in the same direction. So your total EMF is actually total potential difference. Because this is a closed circuit, they must be used up by the resistor, okay? So because they are in the same direction of current, connected in the correct way, so the total EMF actually should be 6.0 plus 6.0 equals to the potential difference. This is a series circuit. Current will be the same. That's why just now they're asking you to find the current. Okay, so current is the same times with total resistance. Now we got 3 resistor right now. Okay, so here is 12.0 equals to the current is 1.5. So we got resistance 4 plus 1.5 plus R. So your answer for your R should be 2.5 ohm. Okay, this is the reason why they guide you to find current first, then using the current, find out the R. Okay, 10 seconds for those who haven't complete. Okay, you complete it. Same direction, so EMF we add it up together. Okay, then equals to the potential difference. Because EMF is provided, potential difference is the gain. Okay, the gain. So voltage will drop across the component. Okay, so we got 3 components, and then these 3 actually in series, so current will be the same. So just now in the first question, they asked you to find the current in the circuit, So we're just using the 1.5, put in into formula. Okay, done? Okay, here next, last question. The resistance R of the variable resistor is now increases. Oh, okay, this is a variable resistor. So that means that variable resistor, it means that we can adjust. Okay, we can adjust, manually adjust. Okay, so now we increase this resistance. State and explain the effect of increase in R. So we increase this one in R on the power transformation by each of the battery. Okay, so what happened to your power? Think. Prasan, let me read. Power, yes. Correct. Prasan, correct. Good job. Wesley. Wesley, correct. But one more important reason. What happened to your total resistance? Wesley, what happened to your total resistance? Now your answer all correct. But add one more point. What happened to your total resistance? Washini. Washini, last one. I read. Wesley, correct. Fatima, when resistance like this, what happened to your current? Current is changing. Their current is changing. Sean, correct. Sean, correct. Okay, now I read Vashini one. Okay, here, when Vashini said when resistance R of the variable resistor increase, total resistance in the circuit increase 1 mark. Hence, current decrease. Yes, resistance increase, then your current will decrease. And based on P equals to VI, when current decrease, power transformed by each battery will decrease. Exactly. Okay, perfect answer. So first point, resistance of the resistor increase, variable resistor increase, that means your total resistance increase. So total resistance increase 1 mark, current decrease 1 mark, then P equals to VI, current decrease, power decrease, 3 mark here. Okay, so I write down the answer. So power decrease. Okay, why? It's because total resistance increase. Okay, total resistance increase, current will decrease. So Fatima, resistance and current is related. Current should be decrease. Decrease. Okay, so P equals to VI. So here the current decrease, so your power should be decreased. V at here, battery, that means that the EMF, the V at here is actually the EMF. It doesn't change. Now it's talking about the resistance change. We didn't change the EMF, okay? So at here, this is one of the methods, one of the explanation, 1 mark, and here 1 mark. Okay. They also accept with others, or you say that P is directly proportional to I. So I decrease, then the power will I decrease, then power will decrease. Actually, same as us. Okay, current decrease, power decrease. Or they say power is okay, they're using formula V square over R. So actually this one, power is directly proportional to 1 over R. So when your R increase, then your P should be decreased. Okay, actually it's the same. You can using whatever power formula. So for this one is they're using P equals to V square over R. The V is the EMF because now we're talking about the battery. Okay, so EMF is a constant value, square, so doesn't matter, divided by resistance. So power is directly proportional to 1 over R. When R total resistance increase, power will decrease. Okay, this one is all. So Vashini answer is good. Okay, any question? No response. Any question? Okay, Fawa okay, Fatima. Vashini, Fatima okay, let me. No, no question. Oh, okay, okay.